Welcome everyone to another lesson on Khadija Academy. Before we start this lesson, hit the subscribe button, the notification bell, and the like button for the YouTube algorithm. Now let's go and start our lesson. What is important now to understand in this lesson, what is exactly static synchronous generator? So we know that any synchronous generator, as I just explained in the previous slide, is that we can control how much active power and how much reactive power. Now we can actually change or convert any system into a synchronous generator without any rotating part. So remember, the synchronous machine is a rotating machine. It has a rotor that rotates and the stator, right, consisting of two parts. Now for the static synchronous generator, it mimics the behavior. It mimics the behavior of the synchronous generator without any kind of rotating parts. Instead, it uses power electronics and the control systems to generate electricity, and hence the term static. Okay, so what I mean by this, for example, if we have a solar energy system or a wind energy system, we can take solar, which is DC, and convert it into AC at the grid side by using an inverter. Interface here using an inverter. Now we can control how much active power, reactive power fed to the grid by controlling the switching of the inverter itself. Okay, so we have a DC source here like solar energy and fed into an inverter that it changes DC into AC. However, this is a fully controlled three-phase inverter. Okay, fully controlled three-phase inverter in which we use IGBTs parallel with the anti-diode. Okay, in order to control or change DC into AC. Now the question is, how can we control active power and reactive power? This is achieved by using a control system. Now when we do this, this whole system, which you can see here, the DC source plus the control system here for the inverter, all of this system together gives us the static synchronous generator. Why? Because it mimics the behavior of a synchronous machine, a rotating machine. In a rotating machine, we can control active power and reactive power. Similarly, by using inverter with a control, we can control active power as if we are using a synchronous machine, right? And this type is called a rotating machine. However, this one is static because we don't have any kind of rotating parts. We have only switches that mimics this behavior. Okay, now what about other sources like wind or any other type? For wind, for example, what we do is that we have our wind generator, any type of induction generator. This produces a variable voltage, variable frequency. Variable voltage and frequency. Why? Because the speed of the wind is changing all of the time. So when the speed of the wind changes, the speed of the shaft of the generator itself or the wind turbine, it changes with time, giving us an output voltage and output frequency which is varying with time. So we cannot connect this to the grid. So what we do is that we add here a rectifier that takes this variable three-phase, variable voltage, variable frequency, and convert it into DC. Okay. However, to be more specific, we don't convert it into a battery source like this. We actually have a capacitor bank which will be connected to our inverter like this. So we will have a capacitor bank that acts as a link or a DC link between rectifier and inverter. Okay, Similarly, as this battery, it doesn't matter, but this capacitor bank has a very important functions, as we will see in the wind energy course or in this course. Okay. So I hope you get now why it's called static synchronous generator. Now this type belongs to the family of static synchronous compensators, STATCOMs, if you have ever heard about them. They are used in transmission systems. They are used to voltage control, reactive power compensation, and power factor correction. All of these functions actually can be also achieved here in this inverter by controlling its switching action or the switching pulses. We can control reactive power, we can control the voltage here. You will see that this point of connection with the grid, this point of connection has a very important concept or a very important name. Its name is actually called the point of common coupling. Point of common coupling, the point at which we are coupling with our grid. Okay, the PCC. Remember this name because you will see it a lot. Now these types here, as you can see, can use to reactive power support, volt stabilization, can make this voltage at a certain value, 1 per unit. Okay, VBCC, voltage at point of common coupling, 1 per unit, as we would like, by controlling this inverter. And also we can synchronize with our grid. All of this you will see in this course. Now these are used in a really important applications like renewable energy integration, grid stabilization, and industrial power system. Now I have used static synchronous generators, which were formed of rectifier, then a DC link capacitor, then inverter, which is used to connect a wave energy resource, one of the devices that are used to convert wave energy into electrical energy. And I have integrated it into the power grid using these converters, using a back-to-back converter, which we will see inside this course. Thank you for watching this lesson. I would like to invite you to our academy, Khadija Academy Premium membership, which will help you learn more about electrical engineering. In this academy or in the academy membership, you will find that we'll have more than 100 courses in math, electrical engineering basics, power engineering career preparations. For example, we have electrical design, we have courses on electric circuits, power electronics, ETAB, MATLAB, solar energy, wave energy, wind energy, and much more. You can join our membership for just a small fee per month, or you can just have a lifetime access in which you will get all of current courses and classes, and you can have them forever. And not only this, but any new courses that will be created, you will be able to watch it for completely free. So what are the classes that I will learn in this membership? You will find different classes in electric circuits, you will find in transformers, magnetic circuits, machines, power electronics, load estimation, lighting design, lightning also design, earthing system, cables, generators, light current systems or low current systems, off-grid design, on-grid design. Very lots of classes and courses in different topics.